Today I'm going to walk you through a day in the life of SafeNet AT products. So rather than kind of bombard you with a whole sequence of PowerPoint slides with product details and information like that, I'm going to walk through how the products could actually be used. And rather than actually taking some customer-specific use cases, I want to go across the gamut and show how in a theoretical environment or a hypothetical situation, how a number of products could be used behind the scenes. So hopefully this will challenge your mind a little bit when either you're looking to see as a partner where the products can be used, or as an end user, you're not understanding exactly how the products behind the scenes could be used to provide critical data protection security. So we'll kind of walk through a hypothetical situation. We'll describe, we'll start with kind of this land far, far away. The backstory is the U.S. has been deployed for a number of years, has been collecting information in a military environment with imagery, intelligence information, and hypothetically, let's say there's an earthquake that takes place in that area. And so the U.S. wants to send in some personnel resources to, stand up a field hospital. And the question is whether or not it's safe to do so. Let's kind of walk through this scenario. We'll start with image collection. So in the crypto world, typically talk about Alice and Bob as our hypothetical people. So we'll use some different characters here. So we'll start with Elaine. So Elaine's a military officer. So she's been deployed in this military zone and been basically in charge of collecting imagery, right? So she's using drones, UAVs, things like that, and actually collecting this imagery now that the earthquake is taking place and sending this imagery down to a military vehicle where that data is then stored, then transferred back to a field outpost. So we go over to the field outpost. There's outpost operations going on. So you have a person named George that's manning the outpost, right? So he's collecting all this imagery from the field units. This data is being consolidated in local storage, and then it's going to be kind of transferred back from this field outpost back to a data center on U.S. soil. So we look at the data analysis stage. Back in the U.S. soil, so we have a large data center. So this data has been transferred from the field back to the core, back to the enterprise, where we've got mega amounts of storage here, right? So terabytes and petabytes of storage with imagery archives, right? So there's new imagery coming in from all places around the world. There's historical images. There's intelligence reports about those images. All that information is being stored in this data center. So this is also where the analytics can take place, right? So we've got kind of big data analytics going on that's actually analyzing the data, comparing imagery, intel reports, things like that, to actually output additional intelligence that can get down typically for the war fighter at the end. But in this case, the request is really for a relief agency. So the analysis, so this data center has been going through the transition to cloud computing. So actually a lot of the analysis here in this scenario is being output to a classified cloud environment. So we move to information sharing, right? So now we've got this person, we'll call him Newman, who's in charge of relief agency, and he needs to understand whether or not it's safe for his relief agency to go into this earthquake zone. So he needs to get this intelligence information from the military or the intelligence community to find out whether or not there's bad guys and bad stuff going on in this earthquake zone. So what he needs to do is actually get a request over to the intelligence community to share information in an unclassified environment to explain to him whether or not it's safe for this civilian agency to prepare to go into this environment. And once he gets that information, basically he sends in the field delivery, right? Assuming everything gets the all clear, right? He's going to send in this military or this field hospital to set up in this earthquake zone, former military environment, to deploy and help the victims of this natural disaster. So in this situation, once you get to the field delivery stage, the field hospital has a number of data needs, right? So there's going to be a mobile data center for patient records, probably some level of biometric authentication to control access to this field hospital, and then typically kind of a local network that's stood up with laptops, workstations to actually run this field hospital. So if you step back real quick, so what does this have to do with SafeNet AT, right? It's just kind of a hypothetical situation where there's an earthquake and a civilian agency goes in. So how does SafeNet AT and SafeNet AT's products come into play here? So actually we often ask, so how many different products are being used in a scenario like this? And so we'll kind of come back to that at the end once we go through it. Right now, I'll walk you through it again, and this time we'll kind of go behind the scenes a little bit. So I'll go to the image collection, right? Remember, Elaine is collecting images from the drones. So let's look what really happened. So that data comes down, again, so one scenario here could be that they've got kind of a tactical data center or field deployed system that's actually running something like like a VMware hyper-converged environment running VM encryption or vSAN encryption. So that type of data, a VMware vSAN encryption, integrates very well with SafeNet AT Key Secure, or the G160, which is this unit down here on the left. So the G160 is a small form factor tactical key manager that can be used, among other things, to secure the keys for things like VMware encryption, VM encrypt, and vSAN encryption. You can also run, if you want to run multiple layers of protection, you can run SafeNet AT's Protect File product that runs file server encryption that'll run kind of on top of the vSAN encryption. And then typically, Elaine's going to have a laptop or some kind of a network compute device that she needs to log into, and we can provide a level of strong two-factor authentication using a multi-factor authentication token. In this case, a MIL standard 810G certified tactical USB PKI authentication token, very similar to what's used on SuperNet for smart card access. Same technology built into it, but it's a USB card reader and authentication token built into one. So once we get that, the other thing that's going on at this tactical edge, right, is information sharing. On the right, you see our typical diagram of cross-domain systems, cross-domain information sharing systems that support a variety of use cases, both collection, distribution, and delivery. So in this case, as we're collecting the imagery from the drones and from the UAVs, right, so we're in a typical collection environment. And so this information needs to be shared securely across the domain to different classification levels. So in this case, we have what's called the MTSR, MTS ruggedized, which resides in the tactical vehicle. So this is a small form factor ruggedized cross-domain information sharing appliance that can be used. So as we go beyond the image collection, right, so we move over to the Outpost. So over in the Outpost, recall that George is now collecting this information as it comes in and going to transfer it back to U.S. soil. So what does he have? So in this case, let's say he's running probably a little bit more compute. So, one of our partners is Class Telecom Government. So they have a Class Telecom, the Voyager Tactical Data Center. So let's assume, for instance, that maybe this is running the data center in this edge condition. So on that, we can run things like the virtual key secure, or as I mentioned before, the G160 tactical key secure. So let's, in this case, assume there's a virtual key secure running with the Voyager TDC. Maybe we're again running VMware encryption and 2 layers of encryption to satisfy like a commercial solutions for classified or CSFC environment where we're running protect file encryption to protect the data at rest. The other aspect of this is data in motion. So how do we protect the data that's going from this field back to the core data center in the US? So in this case, we can use some of our high-speed Ethernet encryptors. In this case, we'll use a small form factor CN4010 device, as shown down here, that connects and is interoperable with a high-speed device that'll be residing at the data center. So if we go from there over to the data analysis stage, right? So this is the data center. So the data center, again, where Jerry is looking at all the data. The first thing that we're going to talk about is the I mentioned the high-speed data encryption. So this is layer 2 data protection at the Ethernet layer. So here's the higher speed, higher bandwidth data center version of the Ethernet encryptor that's going to connect out again to these edge devices. So once we're in this data center, they're probably running a traditional data center where they're running, kind of big data analytics, big data storage. So maybe a Dell or NetApp storage array that's doing data at rest encryption. And for those, we also provide key management. SafeNet AT has a key management solution, which is the G460. Which is the enterprise class data center key manager that would be used with the Dell or NetApp storage. So again, if we have multiple layers of file and folder encryption, protect file I mentioned before can be used, was used at the edge to protect the individual files and folders. It can be also used underneath like a big data solution. So if you look at a Hadoop environment or something like that that's running big data analytics across a large number of nodes, you can deploy protect file underneath that in the operating system level to actually protect all that data as you're running your analytics. So Jerry's running his analytics, comparing images that he received versus historical images, and then storing that application data in a secure way. Protect app, if you look up kind of the networking stack, Protect app provides application level encryption. So once this analysis is done, perhaps Jerry's writing some kind of a Intel report and needs to actually encrypt certain information that's in that report. So you could actually use the Protect app application and toolkit to actually encrypt at a real high level to isolate sensitive information and protect that at the application level. Again, Protect app, just like NetApp storage and Dell storage arrays and the VMware, all connects to KeySecure for robust key management and key lifecycle management. Since again this is a classified network, so they're probably using multi-factor authentication. So in this case, they could use our SafeNet AT smart card, the SC650, to do smart card log on to the classified network. So once we get beyond that, right, so we go to the information sharing phase. So in the information sharing phase, right, so we've got Newman who's trying to get the information for Jerry, right, so he needs to send a message over to Jerry, right, so he's sending, first of all, he's going to log into his workstation, right, so in this case, he's running a commercial network, right? So it's an unclassified network. So he's not going to use an SC650 smart card, but he could use the equivalent, like again, the SKey3250, since there are cases where Newman here is going to go out to the field. So he can use a hardened mil standard authentication token, both in the office and in the field. So he'd use that token, log on to the workstation, basically send a message to Jerry, hello Jerry, hello Newman, can I find out whether or not it's safe for me to send in the relief agency. So he sends information, but of course in this scenario, he's running from his civilian agency over to this classified intelligence community network. So he's going to have to run across a cross-domain solution. So this is where our cross-domain solution, or MDEX, comes into play. So this is the enterprise class version, so versus the ruggedized, right? So basically it's going to run in the data center with endpoints, or what we call SDIs, that run on the endpoints to secure the messages and inspect the messages to make sure everything is safe going across that information sharing network. So again, recall that the data center is going to be running high-speed Ethernet encryptors. So down at the edge here at this branch office, we can also run a CN4010 to secure that high-speed network at the layer 2 level to protect that data in transit. And in this case, the agency, the relief agency, is actually running their own cloud environment as opposed to classified cloud. They're running in let's say GovCloud, right? So some kind of a community cloud, and they want to store the data that they receive, the unclassified images of the earthquake damage, and the intelligence reports, the unclassified versions, to this government cloud. So they could use something once they receive this data, like Protect Cloud Storage, which is a fairly new offering from SafeNet AT, which allows them to basically send through this Protect Cloud Storage gateway information that transparently gets encrypted with keys stored in KeySecure, so locally stored keys in KeySecure to store stuff off in a bucket or storage environment such as AWS buckets or Azure blobs. So once the information sharing takes place, right, it comes down to field delivery, right? So now in the field delivery scenario, right, so we've got this field hospital, you got somebody like Cosmo that's kind of running the field hospital, making sure that everything is safe, the people coming into and out of the environment. So how do we do this? So again, let's take an example. Maybe they've got a class TDC, Voyager TDC running there, mobile data center, plus a number of laptops and servers set up. So for this, they're really going to need to run key management. So they need to run key management in tactical environments. They can deploy the SafeNet AT KeySecure G160, and that can do a number of things. First of all, it can be used with another SafeNet AT product called Protect SED, or self-encrypting drives, to actually securely manage the keys for both laptops and the FIPS compliant self-encrypting drives that are running in the Voyager TDC. So again, one single key manager that's going to manage the keys for the self-encrypting drives that are running on the laptops and also for the Voyager Tactical Data Center. So the other thing that comes into play here is there are there's the bad guys, the trying to get in potentially into this field hospital. So you could run something like our Cogent biometric authentication system to do facial recognition or iris scan or fingerprint recognition to basically control access into the field hospital. So if you take a step back, so how many products were there? So I'd have to count again, but last time I went through this, I think I counted 17 different SafeNet AT products that were kind of used in this day of the life of SafeNet AT, kind of this hypothetical scenario. So hopefully you can see that there's a number of environments where SafeNet AT products, you don't necessarily think of the products being used in all these use cases, but certainly behind the scenes there's a lot of opportunity to deploy these products and secure multiple environments, whether it's from the core data center to the cloud, right, to the field. So in this kind of scenario, we've actually gone through and seen the products in use in all those cases, right? So we talk about hardware security modules. Actually, these are used or integrated in often with PKI systems. So if you're running a CSFC solution with a PKI solution, you would use a hardware security module. They're also used internally with the SafeNet AT products like the Virtual Key Secure, the G350. So we mentioned the Key Secure, right? The Virtual Key Secure integrates with the HSMs. We mentioned the Tactical Key Secure G160 is used in the field environments, and the 460 is used on the core data center. The authentication family, smart cards, USB tokens, both the SKey 6500, which is also integrated with the G160, and the tactical form factor SKey 3250. Family of Ethernet encryptors, both the 4010 and the higher speed layer 2 encryption solutions that would be deployed in the core data center. And finally, cross-domain solutions, right? Whether it's the enterprise class cross-domain MDEX solutions deployed in the tactical data center, or the MTSR, which is deployed, the ruggedized version that's deployed on the tactical edge. In summary, so you've got a large portfolio of product offerings from SafeNet AT, and they can be used kind of across a wide variety of use cases and scenarios, some of which you may not come to mind immediately. So hopefully walking through this day in the life of SafeNet AT products is giving you some food for thought as to how these products can be used. If you have any questions, please reach out to us on the web at www.safenetat.com. Thank you.